One of the key things in science is creativity. I think people often overlook that. So last year we worked with the students in Serbia and we did neuroscience experiments. So we developed a whole bunch of ways to record data from the brain and analyze that. But this year we decided to do something different. So we're going to use the information that comes out of the brain, right, either through our muscles or through our eyes or through our heart. And then we're going to do something differently. We're going to have them take that information and convert it into some creative device, right? And so it really lays on that creativity aspect of things, because when you're a scientist, you have to, if everyone does the same thing and you're always looking in the same spot, right, you're not going to get much further in science. And so one of the things we are trying to encourage is to get people to start thinking about things differently, right? And so the student projects that we saw this year even surprised me in terms of creativity, like using tools that I never thought they would use, a plasma box for one of the tracks they were using. So that type of stuff is going to pay back dividends in the future when they start to approach a problem and they start to think about it in different aspects. Because what people often overlook is that the major breakthroughs that happen in science are not because they just thought of something that like no one else did. They literally did something completely different, right? So they went and saw something that everyone else sees, but looked at it from a different point of view, right? And so that different point of view is what art is what creativity is. And we're kind of combining neuroscience and art together to make these projects to get people start thinking more creatively. One thing students often struggle with is when they're tasked to be really good in school, they're often tasked to like memorize stuff and be really, really good for an exam. And when you do that, you lose risk, right? You lose the ability to try things out because you want to get rid of risk so that you get the perfect score, right? Often when you have that, you get students that are unable to do things that are out of the box. Like if you don't give them a clear direction of what needs to be done, they're frozen, right? I was kind of half expecting the Serbian students to do that. But what I found was that it was completely the opposite. So these guys came out and they were doing extremely creative things. We had to bat down the number of ideas they had because they had so many. And so I think that if this is an indication of what is possible with students, I think we have a winner on our hands, because the projects here were incredible. It's not just me saying that, they're absolutely incredible. In the broader picture, this summer was to kind of test something that we had an idea on. About 10 years ago, we released a product with an Arduino. An Arduino is like a microcontroller that you can plug in and connect to your body, for example. But what we found is that no one was really using that. And the reason why is that you have to use C code in this kind of weird editor. And so we tried it again with a microbit. And the microbit allows you to do block coding, so you can get in with low code, almost no code, and then you can switch to Python or JavaScript, and allows for students to kind of like take things that they already kind of know and put that to use. And when you do that, what we're able to see is that they're able within a few days to go from absolute nothing. A lot of our students had no experience with programming, to making computers that do amazing stuff, and it was wowing people in our demonstration. A program like this would be really good for Serbia for the reasons I just mentioned, that it sparks its creativity, but not only does it spark it, Serbia's in a special position. There are many schools, I think there's 9 and counting, that have maker spaces similar to what's here built into the school. And what they need is programming to get kids to understand. Like, there's a lot of maker spaces out there, but almost all of them just have kids sitting there downloading stuff and printing them on the printer, right? They're not quite figuring out how to actually use the tools that are there. And so what this program does, it gives kids the ability to understand how to use the tools. So they're learning how to program using the programmers they have. We have a lot of like 3D printed parts. We're starting to build stuff with like the laser cutters to be able to do stuff. And they're starting to figure out, how do you take an idea and it turn into something that's real? And I think that's something that can be done today in the schools, and it's going to be, they're starting to grow with more and more maker spaces each year. So it's an exciting time. it's going to be a long 10 more years probably, right? I'm Greg Gejdž, so I come here every summer, and so I want to be creative even when I'm in Serbia. So we happen to find each other, CPN and I, through, I think it's through a speakers program with the U.S. Embassy. But anyway, once you find a space like this, you don't want to leave it, right? And so instead of just working by myself, we brought our team here and we're starting to run these workshops. So this is our second year in a row. Next year, we may do something completely different. We might do something on neurorobotics, which are robots that have spiking neural networks to the students' program. We may do something on this new consciousness stuff we're working on. So who knows what the future holds, but I suspect that every year we'll be able to add new programming that's going to be cutting edge on the frontier of neuroscience education.